Hello and welcome back. In this video, we are going to look at the types of digital circuit. In our previous video, we look at what is a digital circuit and we look at the basic logic gates. And basic logic gates are the foundation of digital circuits. Now we are going to look at what is this digital circuit. So there are two main types of digital circuits. Because there are two main types, that means if you look at any kind of digital system around you, they will be either made up of one of these two types. The first one is known as a combinational circuit. So what is a combinational circuit? A combinational circuit is defined as a digital circuit. So remember, a combinational circuit is a digital circuit where it produces an output based on the current input values. If I draw a block diagram to represent a combinational circuit, and this combinational circuit can be a logic gate itself, a multiplexer, a demultiplexer, encoder, decoder, and so on. So based on the idea, on the definition that it is a digital circuit that produces the output Y based on the input X. Example, if it is the AND gate, and we all know what is the AND gate from our previous video, and if we have input A and input B, the output will be Y. Imagine that the X now represent X1 and X2 from this diagram, or we can draw in terms of X1, X2 into the combinational circuit, which is the AND gate, and it will produce the output Y. That means whenever the value of the output will depend mostly on the two input where there is no delay. When I say delay, that means at time t, if t is equals to 1, and at this time we have the x1 and x2 having a value of 1 and 1. At that same instant where t is equals to 1, we will have the output y, which will be equivalent to 1. So we can see the time difference where at this instant when the input is 1 and 1, at that same instant the output will react solely on the input by giving the output value of 1. The important thing to remember is that there are no delay. Whenever the input value changes, at that same time the output values will change. That's why in a digital circuit where the output responds solely on the input values of this digital circuit, this type of circuit is regarded as a combinational circuit. And when we look at a digital circuit, the digital circuit, we can define as when one or more logic gates are interconnected together to perform a function. So when we have a digital circuit, that means we can have one or more of the logic gates that we discussed earlier on. They will be interconnected together to perform a function. That means from this case, we have a multiplexer. If you look at a multiplexer is made up of more than one different type of the logic gates. For example, if we say a NOR gate, a NOR gate can be seen as a combinational circuit where it has now two logic gates interconnected. That means we have input A, B to a NOR gate, and this NOR gate is now connected to a NOT gate where it produces the output Y. So this is the OR gate and this is a NOT gate. So from a definition, if we say a NOR gate, it can be seen as a digital circuit. And since it is under combinational, that means if the input A and B changes, the output will respond to the changes of the input at the instantaneous time. If A and B is 0 and 0, that means the output will be 1 at that instant, so there are no delay in such circuit. Later on, we will explain what is a multiplexer, a demultiplexer, and encoder, decoder, and other set of combinational circuit where you can also design your own digital circuit based on your requirement. Whatever you want to design and you want the output to act at that instant when the input changes, you can now be able to design your own combinational circuit. So now let us look at the second type of digital circuit, which is the sequential circuit. So what is this sequential circuit? A digital circuit that produces an output based on the current input values and the past values of the digital circuit. A sequential circuit is a digital circuit where the output is now based on the current input and also the past input values. So such circuit is called a memory circuit. So when you think about a sequential circuit, you can think of as having a memory. And for a combinational circuit, you can think of it as a non-memory circuit. So some examples are flip-flop, counters, and register. And those type of circuit, as we have seen from these two digital circuit, the types, mostly they can be found in a digital circuit such as a computer, your mobile phone, and switches, and etc. Where this type of digital circuit that we use, they are made up of all these type of combination and sequential circuit. So when we put combinational circuit and sequential circuit together, they form a digital circuit. We call it as a devices. So it is important that you learn what is a combinational and sequential circuit so that you will appreciate how those computer, mobile phone, switches, and any form of digital circuit operate. Because we know that a digital circuit, apart from looking at the logic gauge, which is the basic, we appreciate that they operate using, when we talk about the type of values, we talk about the digital values, and it can be the ones or the zero. So those are the values that can be found in a digital circuit. Let us look at the block diagram of a sequential circuit. So when we have X into a system called a combinational circuit, like we discussed previously, it will produce the output Y. However, when we take the output and giving back as an input, where we call it a memory, fed back into the input of the system. So remember, this is a combinational circuit and this is a memory circuit, and let's say non-memory. So altogether, this circuit is now known as a sequential circuit, where the memory part is added to the combinational circuit itself. Now when we define that the output of the sequential circuit, which is the Y, it depends on the current input, which is the x, and the past values of the circuit. Remember, if we have the output y, we are sending x into the system, it will produce a y. And for t is equals to 1, let's say we pass an input. If this is a combinational circuit made of a buffer. So we all know that a buffer output is equivalent to the input. So at t equals to 1, when we pass a value 1 into the circuit, the output will be 1. And when we say t is equals to 2, we pass a value which is known as a 0 into the circuit. Now, the output will be the value of the past input, which is the 1. We will have the same value, 1 into the circuit. So we will have 0 and 1 as an input to the circuit, which will now produce the corresponding value, which is y. The important thing to remember and differentiate between a combinational circuit and a sequential circuit is that for a combinational circuit, the output is based on the input. However, for the sequential circuit, you can think of it as a combinational circuit with a memory, and the output at the instantaneous time depends on the present state of the input, which can be known as the x, and the past values of the combinational circuit. And these past values is normally fed back to the input. So both the input to a combinational circuit will be based on the present state of the input plus a memory. When we look at the flip-flop, the counters, and the register, we can now be able to see why do we need a sequential circuit and why is it important in our everyday digital electronics such as a computer, mobile phone, and etc. So in this section, I believe you can be able to define what is a combinational circuit and a sequential circuit. And those are the two main types of digital circuit. Now let us look at some examples of combinational circuit. And one, we can say the logic gates. And we all know what is a logic gate. And now we will combine one or two of the logic gates and we can see the result in terms of the truth table. So imagine from scratch, we have the AND gate which have x and y, and we pass it into another OR gate, and this OR gate is now connected to a NOT gate. So we have the output, let's say Q. So we can say X, Y, and Z is the input and Q is the output. Remember, those are a variable which represent the logic. Previously, we say Y is the output. So no matter which variable you use to represent the input and output, it must be consistent. So we can say X, Y, and Z, they are our inputs, and Q is our output. So from here, we know that the X, Y, and Z, they represent a binary state, which the output, the changes is mostly depend on the input. So when we want to find the combination of the circuit, of the input and the output, where since it is binary, we have the base of 2 and n represent the input. So when we have 2 to the power of 3, because we have 3 input, we will have the output combination that is 8. So 8 set of input combination will produce the output. So this type of circuit is a combinational circuit where when the output Q changes, it will mostly depend on the changes in the input. So when the variable X, Y, and Z, they change state from 0 to 1, 1 to 0, and in any order, the output Q will mostly be determined by these input values. When we say we want to draw a truth table that will represent this type of combinational circuit, and we know that there will be 8 combinational output. So our truth table will be input X, input Y, and input Z will produce the output Q. So when we draw such circuit, we can also label as the input and the output. So we can have 8 combination of the input values that will produce the output. So we can see we have 1, 2, 3, 4, 5, 6, 7, and we should have the last one, which is the 8th. So this represents the input and Q represent the output. Now let's have the input combination. So the input can be 0, 0, and 0, and it can have 0, 0, 1, 0, 1, 0, 0, 1, 1, and 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So that means the input can have only these 8 combination and not more than that. And also we can have the expression. We can derive the expression of the output Q that will produce from the input, which is X, Y, and Z. So the block diagram can be having the expression, and we can have input X, Y, and Z, which will produce the output Q. So what will be the expression? So to make it simple, I suggest you can perform by looking at the output. So you perform some form of equation. So you have A, and you can have B, and you can have C. Those represent the output of the logic gates. So to derive, we can say A is equivalent to X dot Y, and B can be equivalent to A plus Z, and we can say Q is equivalent to B bar. So when we say B bar, where it can be equivalent to C. So Q is equivalent to C, and it is the inverted of the input B. Now if we want to substitute this one, we can see that B is equivalent to X dot Y plus Z, and C is equivalent to X dot Y plus Z and bar inverted. So this is our expression of the circuit, where we can say Q is equivalent to C, which is equivalent to X dot Y plus Z inverted. So by solving this combination, when we substitute these values into this equation, now we can use the output to fill in this table. Later, we will look at some of the method in which we can simplify a circuit. But for this example, we are going to look at a straightforward way in which you can be able to determine the output based on the changes in the input. So that means at time, let's say t is equals to 1, and t is equals to 2, t is equals to 3, 4, 5, 6, 7, and 8, where at this time, we have the changes which is represented in that manner. And t7 and t equals to 8. So that means at the first 1 seconds, we will have this input. And then in the next second, which is the time is equals to 2 seconds, we will have this value 0, 0, 1 at the input. So this is our input, and the input is now based on the time. So when the time changes from 1 to 2, we have the changes in the input and what will be the corresponding values of the output. So at t equals to 1, we will see what will happen to the output. When t is equals to 2, what will happen to the output values all the way to t is equals to 8. So when t is equals to 8, we will have these values, and at the same time at t equals to 8, we can see that the output will changes based on the change in the input values. So there are no time delay. That is why we call it a combinational circuit. If you like our video, you can kindly click the subscribe button and like our video, and also share this video with your friends so they can be able to learn and understand why do we need to learn a digital circuit and why is it important in most of our everyday devices that we use. Now all you have to do is that when t is equals to 1, what will be the output q? So we just substitute this value x, y, and z into this equation. When we have 0 and 0, we should have 0. And when output is 0, we have 0 plus 0 is equals to 0 inverted. When we invert 0, it will now becomes 1. So we can simply plot the output, which is 1. So this is how you analyze the circuit. So at time t is equals to 2, what will be the output where we have x and y, which is 0.0 plus the output is 1. So it will gives us 1 inverted. We should have the output 0. So we simply fill in the table by inserting a 0. And for t is equals to 3, what will happen? We have 0.1 plus 0 inverted. So we should have 0, and inverted we should have the output, which is 1. And for t is equals to 4, we should have 0.1 plus 1 inverted. So this portion will become 0 plus 1. It will be 1 inverted. We should have 0. So this will become 0. For t is equals to 5, we should have 1.0 plus 0 inverted. So we should have this portion will become 0 plus 0 is 0 inverted. So the output will be 1. So we can fill in 1. And for t is equals to 6, we should have 1.0 plus 1 inverted. So we should have this portion becomes 0 plus 1 inverted. We should now get 1 inverted, and it should be 0. So we fill in 0 in this portion of the output. And t is equals to 7, we should have 1.1 plus 0 inverted. So it should give us 1 should be give us 1 plus 0 inverted, which should gives us 1 inverted. We should get 0. So we simply fill in 0 at the output. Finally, when t is equals to 8, we should have 1.1 plus 1 inverted. So this portion becomes 1 plus 1, and which will gives us 1. Inverted, we should have 0. So we fill in 0. So now the output is corresponding to the input at that instantaneous time. When t is equals to 1, we should get the output 1. When t is equals to 2, we should get the output 2 based on this input combination. So by looking at this expression and how we derive from the circuit diagram and the truth table, you can now be able to solve any kind of digital circuit that is known as a combinational circuit, where we have more than one logic gates connected together. So if you are given any expression, then the important thing for you to know is to firstly find the combination. For example, if we have a circuit and it has a expression, and expression can be in the form of the input and the output. So if we have 1, 2, 3, and 4, so you will have only one output Q. So we can have X, Y, Z, and let's say M. So the first thing you should do is you should find the combination 2 to the power n. So 2 to the 4, which will give us 16 combinations. So you will draw a table which will have combination 1, 2, 3, 4, all the way to 16. And the output of such combinational circuit can be derived from the changes in the combinational input, and it will produce the output correspondingly. So by given any expression, a circuit diagram or a truth table, they are interconnected. If given an expression, we can say expression, it is corresponding to the truth table, and the truth table is corresponding to the circuit diagram. So all of this, if given the expression, you can be able to find the truth table and the circuit diagram. Or given a truth table, you can find the expression and the circuit diagram. When given a circuit diagram, you can find the truth table and expression. So I have made this video, which can be a simplified way, which can help you understand how the circuit diagram expression and the truth table, they are related to each other. And this type of circuit is the combinational circuit. Later on, we will look at some of the rules that can help us simplify a circuit. But to understand the rules, you should firstly know how to compute from scratch, such as what we have derived in this example. So some of the application we can see from the combinational circuit, where we have mentioned such as a multiplexer. So for a multiplexer, we can have 1, 2, 3. So input 0, input 1, input 2, all the way to input n, and we have the Q as an output. So from here, we can say we have multiple input, and the output, we have a single output. And for the demultiplexer, we can have a single input, let's say I naught, and we can have Q0, Q1, Q2, all the way to Qn. So in that case, we can see we have a single input to the demultiplexer and multiple output. So we can see the difference. So from a system known as a combinational circuit, we can have multiple input and single output, single input, multiple output. In our later video, we will look at the system having single input and it has single output, and then we can have single input, multiple output, and multiple input, single output, or multiple input, multiple output. So those can be our system. So in some of the example, you will come across where it is a combinational circuit, but it has multiple input and multiple output, or multiple input, single output. And we can see from the example such as a multiplexer, or the example such as the demultiplexer. So demultiplexer can be a single input, multiple output, and demultiplexer can be multiple input, single output. So those are under a digital circuit. So we have many applications of the use of a combinational circuit, where later on we will look at the processor of a computer, where it has the arithmetic logic unit, and for example a traffic light controller or a digital thermometer. More of the application that we will look on later on, they will mention a combinational circuit in it, where if you can see from this type of circuit where there are no memory, where the output Q is mostly determined by the changes in the input. And later on, we will discuss what is a multiplexer in a simplest form, where given the equation and the truth table, so you can fully understand what do we mean by a combinational circuit. And to fully understand a digital circuit, you can continue to watch the full course starting from the beginning till the end. So by following step by step, you can fully understand this type of course and its importance in our today's world, because most of the devices that we use, they have digital circuit. So when you understand these rules and the expression, the truth table, you can fully understand and analyze a circuit. So if you want to perform troubleshooting, it will also becomes important, because you know where a signal is passing through one point in a circuit, such as the input and the output. If you know that this type of circuit produces an input and the output is not corresponding to the input, that means, for example, you have 1 here, 0, and then you have 0, 1, 0, 1, 1, 1. Although you have this type of circuit, so you can know that there are something wrong with the circuit because the response of the circuit is not corresponding to the input. So you can fully analyze the circuit. That is why they give you a truth table and the expression or the circuit diagram itself to help you fully understand this type of system and how it behaves.